Hello students, we are continuing with the chapter hydrogen. Okay, in the last class we have studied about the placement of hydrogen in the periodic table, where it should be placed, why it should be placed, and we have studied about the physical properties of hydrogen and chemical properties. Today we are going to study about the hydrides. So when I say the word hydride, what does it mean? It means this hydrogen is reacting with a non-metal or a metal, okay, to form the corresponding hydride. Suppose the metal, if we have taken magnesium, it reacts with hydrogen to forms magnesium hydride. If we take sodium with hydrogen, it will form sodium hydride. Okay, we can take some non-metals also, and in non-metal also, if we add hydrogen, hydrides are formed. Very common example is of ammonia, okay, NH3. Okay, now here we are seeing that yes, hydrides are formed with the metals and non-metals, but not with the noble elements or the noble gases, because they don't require to participate in the reaction, as its octet is totally complete. Okay, so when we talk about the hydrides, okay, these hydrides, if we say, it is basically of three types. Okay, first is ionic or saline or salt-like hydride. Second one is covalent or molecular hydride, and the third one is the metallic or non-stoichiometric hydrides. Let us go with first with this one, ionic, saline or salt-like hydride. When I say ionic, the thing comes in our brain that yes, here what is happening? The ionic bond, maybe formation of ionic bond is taking place. And when we say about the ionic bond, it means here in the last valence cell, the electrons present are very less in amount, so that the ionic bond can be formed. So yes beta, basically most of the S block elements, okay, forms this type of hydride, that is ionic, saline or salt-like hydrides. When I talk about the S block elements, it is group 1 and group 2, the alkali metals and the alkaline earth metals. Okay, now if we say about what type it might be, they are white crystals, okay, and these crystals, color is white and it consists of what? Ions. Why? Because here giving of electrons are taking place, electrons are being transferred. Okay, so here electrons are transferred from where? This S block elements to the hydrogen. Okay, so here ionic bonding is taking place, and this type of salts are white crystals and they consist of ions, the positively charged ion and the negatively charged ion. Okay, so for example, if we are taking sodium hydride, NaH, okay, sodium reacts with hydrogen, Na reacts with hydrogen to give NaH, isn't it? Here what is happening? The electrons are being transferred to hydrogen, ionic bond is taking place. Okay, now here when we talk, yes, only ionic bonds are present, but yes, no, the lighter this metals, exception is there of lithium hydride and beryllium hydride. Okay, here we are seeing that instead of being ionic in nature, they are covalent in nature. This is because of the anomalous behavior of this lithium and beryllium, as they are the first elements. Lithium is the first element of group 1 and beryllium is the first element of group 2. And yes, they show differences in the characteristics with the other elements present in the same group. Why they show this type of characteristic, different characteristics? Because their atomic size is very, very small. Okay, when we talk about the electron negativity value, here also we see that yes, there is a difference. Okay, when we talk about the d orbitals absent totally. Okay, so these all things makes them different from the other elements present in that same group, and as the result, instead of forming the ionic bonds, they form the covalent bonds. So these hydrides, the lighter metal hydrides, lithium hydride and beryllium hydride, they are covalent in nature. Okay, now next coming, like beryllium hydride and magnesium hydride, we are seeing that yes, they are forming polymeric structure. So what do we mean by this polymeric structure? Actually here they don't exist in the single form. Okay, they will form the chains, and as the result they form a polymeric structure. Okay, now if we talk about this ionic hydrides, this when reacts with water, what happens? Violent reaction takes place. Why does it take place, violent reaction? You can see that yes, sodium hydride reacts with water to form sodium hydroxide and hydrogen gas is given out. Okay, actually these are very reactive elements, and as the result when they react, okay, with water, the reaction is violent, giving, if we are taking sodium hydride with water, it will give sodium hydroxide and hydrogen gas will be evolved. Okay, so yes, we are saying that they are having what? The ionic bond. They are ionic in nature. Naturally, if they are ionic in nature, electrostatic force of attraction is too much, isn't it? Because one is taking the electron, one is giving the electron, as the result making its melting point as well as boiling point high. Okay, when we talk about does it conduct electricity? Yes, they do conduct electricity, but not in the solid state, in fused state, or we can say in the aqueous form. Okay, otherwise if it is in solid form, ions are not free. As the result, naturally it will not conduct electricity. Okay, now here you can see that yes, this type of ionic hydrides, okay, they form complexes. Okay, and as the result, as they form complexes, here we are seeing that they are used as reducing agents in many of the organic reactions. Okay, like we see this lithium hydride, it reacts with this aluminum chloride, okay, and it gives what? Lithium aluminum hydride plus lithium chloride. This lithium aluminum hydride, okay, in organic chemistry you will be seeing that this is used as a reducing agent. Okay, now coming to the covalent or the molecular hydride. As soon as this word covalent comes, it means what? Here we will be seeing the covalent character, isn't it? And here we are seeing, as in ionic hydrides we have seen the S block elements participating. Here in covalent or molecular hydride, we see what? The P block elements participate to form this type of hydrides. Okay, so here basically this covalent or molecular hydride is again divided into three or classified into three. The first one is the electron deficient hydride, okay, electron precise hydride and electron rich hydride. So what does this mean actually? Let us understand. Okay, so here electron deficient hydride, when we see here, we are seeing that yes, group 13 elements, they form this type of electron deficient hydrides. Okay, they don't have sufficient amount of electrons to form any normal covalent bond. Okay, there is deficiency in the number of electrons. Okay, here also we will be seeing that yes, they form polymeric forms. It means number of them joined together to form this type of compounds. Okay, and here we are seeing that as they are electron deficient in nature, they will try to accept the electron, and as the result, if they are accepting the electrons, they act as Lewis acids. Okay, as we are seeing that yes, they have deficiency of electrons, naturally they will try to accept the electrons, isn't it? And when they are accepting the electrons, they act as Lewis acid, or they are Lewis acids. Okay, examples like you can see over here, B2H6, B4H10. Okay, let us understand this covalent or molecular hydride, the electron deficient hydride, with the example of B2H6. Okay, so here we are seeing this boron. Okay, 2 boron. Okay, here 6 hydrogen is there. This hydrogen you can see over here, it is forming a bridge between these 2 boron atoms. We all know hydrogen has got only one valence electron. Here this hydrogen is acting as a bridge between this boron and boron. There is deficiency of electrons, and as the result they form electron deficient hydrides. Okay, now coming to electron precise hydrides. Okay, when we talk about electron precise hydride, here basically which group participates in the bond formation? That is group 14. Okay, and this group 14, that is the carbon family. Okay, and here we are seeing what? They form a tetrahedral shape. Okay, let us understand this electron precise hydride with the methane. Okay, here we see what? Carbon is joined, it has got 4 valence electron. Okay, and it is joined to hydrogen, isn't it? So what happens over here? Here we don't see any valence electron or any other electron which is extra present over here, nor we see that yes, there is any deficiency, because this hydrogen is having only 1 valence electron, carbon is having 4, and naturally it is forming the bond, and this all its carbon's octet is complete and hydrogen duplet is also complete. Okay, so here we are saying that they are electron precise hydrides. Okay, now talking about the electron rich hydride. Okay, what happens in this? We are seeing that they are the groups 15 to 17, they form electron rich hydrides. Okay, if they are rich in electron, naturally what they will form? What are they? They are Lewis bases. Because they are rich in electrons, they can give these electrons, thereby forming what? Lewis bases. Okay, let us understand with the example of phosphorus hydride. Okay, we all know the atomic number of phosphorus is 15. Okay, so now do the configuration. Okay, 2, 8 and 5. Okay, so here see the bond formation for phosphorus pH3. Okay, here you are seeing what? This 3 hydrogen has been attached. Okay, and here 2 electrons are present, 1 lone pair of electron is present. So here it is after forming the formation of the bond, still there are 1 lone pair of electrons, thereby stating that this is what? A electron rich hydride. Okay, where after forming the bonds also we can see that yes, 1 lone pair of it present in that compound. Now coming to metallic or non-stoichiometric interstitial hydrides. Okay, actually this non-stoichiometric metallic interstitial hydrides, they are formed by D and F block elements. Okay, their atomic number is too much, isn't it? They have the property to conduct the heat and electricity. They are mainly what? The transition metals and the inner transition metals. Okay, they always form what? Non-stoichiometric hydrides. Okay, which are being deficient in hydrogen in a very minute form. Okay, actually what happens in this? In this, we all know that yes, when we study about the solid structure or the metal structure, okay, solid state, we see that they have got interstitial spaces. Okay, these interstitial spaces, what happens in that? Hydrogen gets adsorbed. Okay, adsorbed. It means there only at the surface of that metal the hydrogen is present and it is attached, and that is only the adsorption. Okay, and when we see about the adsorption, it is not so perfect. Okay, there will be less amount of hydrogen adsorbed on the surface of the metals of this D and F block elements. Okay, so here we are seeing that yes, when the adsorption is taking place, here you can see that for hydrogen I have written over here 2.87, okay, 2.55, okay, here at zirconium hydride it is 1.3 or 1.75, and here I am showing variation. Okay, what is this? Actually what happens, here we are seeing that yes, some less amount of hydrogen with respect to the element has been adsorbed on the surface. In zirconium we are seeing that yes, there is a range 1.3 to 1.75. Actually what happens in this, it depends upon the temperature and the pressure what we are providing to it. Okay, and with the increase or decrease in pressure or increase in pressure and decrease in temperature, there will be difference in the absorption rate, and as the result, more or less, okay, hydrogen will be absorbed accordingly on the element's surface. Okay, and this is why we are seeing that here these elements, they are used as catalyst. Okay, and they are interstitial hydride formations they form by when we use it in the form of a catalyst. Okay, now let us study about water. Okay, we all know the formula of water, that is what? H2O, isn't it? Now, what is the structure of this H2O actually? When we say H2O, water, it exists in three forms: solid, liquid and gaseous form, isn't it? And does it have the same structure in case of solid, liquid and gases? Let us study about that. Okay, so structure of water when it is in gaseous phase, it means what? When it exists in the form of water vapor. Okay, so here we see that yes, this water has got bend shape. Okay, actually what happens over here, the angle it forms is 104.5, and yes, the bond length between oxygen and hydrogen is 95.7 picometer. Here we are seeing that yes, oxygen is negatively charged partially and hydrogen is partially positively charged, even though it is forming a covalent bond, but yes, slight polarity is there as oxygen is electronegative in nature, and due to this polarity, this hydrogen has got a bent shape. Okay, because what happens, as oxygen is more electronegative in nature, polarity is there, we are seeing what? Yes, the bond is been formed in which one is slightly positive in nature, one is slightly negative in nature, making it what? Stretch and distort and form a what? A bent shape. Okay, now when we talk about liquid phase, we all drink water that is in liquid phase, isn't it? Here we see what? Here, this water molecules, okay, they are joined together with intermolecular hydrogen bond. Okay, and they have got very profound efficiency. Okay, this oxygen has got here also lone pair of electrons, but yes, with what? They are joined, intermolecular hydrogen bond. Okay, and as the result you can see this liquid water in this form. Okay, but when we go to this solid state of water, okay, that is the ice. Okay, it has got a 3D structure or 3D bond formation. It means three-dimensional hydrogen bond it has got in case of solid state of water, that is ice. Okay, here you can see this, the structure of ice. Here also hydrogen bonds are present, but here there is a large space. Okay, in case of liquid we have seen that here space was less, but in case of solid we are seeing that here space is more in this hydrogen bond, and this is due to this this open spaces, this density of ice becomes less than water. This whole structure gives the ice a cage-like structure having spaces in between it due to this big space of hydrogen bond formation, okay, over here, and thereby giving the lesser density of ice than water. Okay, so here let us understand one more phenomenon. Okay, we see that at the surface of the water, okay, the ice is floating. Okay, it is a solid. It should not float, isn't it? But here it is floating. Why? Because this shape, the cage-like structure, the space is present in this H2O molecule, okay, makes its density less. Because here you are seeing that what happens over here, the density becomes less, okay, in this because of this open spaces. Okay, so as the result what happened, it will float on water rather than sinking in it. Okay, so let us understand this phenomenon. Actually what happens over here at 273 Kelvin, okay, or 0 degrees Celsius, the water is present in the form of ice. Okay, but now suppose if the temperature is increased by 1 degree or 2 degree, what happens over here? If it is increasing, this bond starts breaking. Okay, and as the result, when it starts breaking, what happens? This H2O molecule starts coming near to each other. Okay, and when they are coming near to each other, now the space is less, isn't it? And as the result, its density will become more. Okay, now if the temperature is increased till 4 degrees Celsius or 277 Kelvin, okay, we are seeing at this position the density is maximum. Okay, but yes, if temperature is again going on increasing bit by bit, what will happen? We will be seeing that there is what? Increase in volume as the temperature is increasing, and as the result what will happen? Expansion will take place. Okay, and as the result what will happen? If the expansion is taking place over here, but as with that we are seeing that yes, here what is happening? The volume is also decreasing due to the hydrogen bond is breaking due to the rise in temperature. Okay, more rise in temperature. Now the volume is increasing as the temperature is increasing, isn't it? And as the result there is an expansion, and yes, if it goes on increasing, naturally it will be converting into the liquid form of water. Now the question arises, why does this fish or the aquatic animals survive? Okay, if the ice is present above the surface of the water, the temperature becomes too cool, isn't it? If the ice is there. So what is the phenomenon behind it? Okay, actually what happens here? The surface molecules of the water, they participate in the formation of ice as the atmospheric condition over there, the temperature is too low, isn't it? So what happens? The surface layer, the surface molecule of the water is what? They are free. Above that no water is present. The intense temperature is low. And as the result, here formation of ice takes place. But what happens? As the formation at the surface of the water, the ice takes place, inside it, it remains water only, because this surface of the ice, okay, now disconnects the temperature which is at the environment or the atmosphere at that place with the water below the ice, isn't it? And as a result, here what we are saying, this is remaining in the water form only this is forming the ice. And if it is in the water form, naturally here the temperature is not so less, because this has disconnected, this layer of ice above it has disconnected the atmospheric temperature which is too low with the water present beneath it. Okay, and as the result the aquatic animals can survive very easily. Okay, we can see many of the places, okay, if you go and visit, okay, if you see that yes, a layer of ice is there, try to break it and you see that yes, when you dip your hand, the temperature of the water is not as low as the ice or the surface of where this ice is present. Now let us study about the physical and chemical properties of water. Okay, first we will be studying physical properties. Okay, so when we talk about the freezing point, the boiling point, the heat of fusion, the heat of vaporization, actually it is higher than what when we compare it with hydrogen sulfide. Okay, why it is high if we compare it with hydrogen sulfide? Why the freezing point, boiling point, heat of fusion and heat of vaporization is more than H2S? Actually here what is happening, here we are seeing what? Intermolecular hydrogen bonds. And due to this intermolecular hydrogen bonds, the freezing point, the boiling point, the heat of fusion and heat of vaporization becomes more in case of water rather than H2S. Okay. Second, we can see that yes, the specific heat capacity of water is too high, and this is due to which it can absorb tremendous amount of heat, okay, with minimum rise in temperature. What happened? You have seen in the cars, radiators of the cars, what happened? We apply water as a coolant in them, isn't it? Why do we apply that? Because the specific heat capacity of water is too high. It can absorb that heat and its temperature also doesn't rise too much. Okay, so here we see that the specific heat capacity of water is too high. Okay, now it is poor conductor of heat and electricity. Actually what happens, this water when we see H2O, okay, here this is weakly ionized to H plus plus OH minus ions, okay, and as the result what happens, this does not conduct electricity properly, and it is a bad conductor of heat. If we want it to conduct electricity in a more efficient manner, we have to add acid to it. And yes, if the acid is added to it, its efficiency increases. Okay? Now, when we see water, water is a polar molecule, isn't it? Why it is a polar molecule? Because here we are seeing oxygen is joined with two hydrogen. Okay, hydrogen being slightly electropositive in nature, and here oxygen is electronegative in nature. Naturally, what will happen? It will give it a polar nature, and here we will be seeing that yes, the polar compounds can dissolve in this water very easily, like NaCl if we see, Na plus and Cl minus. If we want to dissolve in water, water also has got polarity, and as the result it can dissolve easily. When we talk about the organic compound, okay, they find difficulty in dissolving in water because organic compounds are not polar in nature, okay, but yes, some organic compounds are soluble in water. Why they are soluble in water? Because they consist of hydrogen bonds. Okay, now we see that if the first property we should have discussed, that is what, that is water is, how does it look like? It is colorless. Does it have color? No. So it is colorless. Okay, you drink it. Does it have any taste? No. If you add anything in it, then you get the taste. Otherwise it doesn't have any taste. Does it has any smell? It is odorless. It doesn't have any smell. Okay. Now, coming to the chemical properties of water. Okay, so chemical properties, when we talk, it means what? That how it is reacting with other substances. Okay, and what are the products it is forming. Okay, so we see that yes, this water is amphoteric in nature. What do we mean by that? It is amphoteric in nature. It reacts with acids as well as bases. Okay, and as a result, it acts as an amphoteric substance. Okay, like for example, if we see NH3 plus H2O, okay, here we see that this H2O is acting as an acid and NH3 is acting as a base, thereby forming what? Ammonium ions, okay, and OH minus ions. Okay, here we are seeing the conjugate acid and the conjugate base. Okay, you all have studied in the Bond-State-Liouville theory. Yes, this base will form a conjugate acid and the acid will form the conjugate base. Okay, now likewise, if it reacts with water, reacts with H2S. Okay, so what happens over here? Here water is acting like a basic substance and H2S is acting as an acidic substance, thereby forming H3O plus and HS minus. Okay, now this amphoteric nature of the water only gives this water the property of what? This self-ionization of water or autoprotolysis, in which we see that yes, water with water itself, okay, it forms what? Acid and base, that is H3O plus OH minus ions. Okay, now here we see that yes, this hydrogen can react with sodium, carbon dioxide, okay, fluorine, here and many other substances, not only this, okay, showing what? The redox reactions. Okay, see this hydrogen, okay, water reacts with sodium, okay, to form what? NaOH plus hydrogen is given out. Okay, so here we are seeing what? In this, it is oxidizing and reducing, thereby giving a redox reaction. Okay, now here with carbon dioxide, it is forming what? C6H12O6, that is glucose plus water plus oxygen. Here also we are seeing that yes, here it is following the redox reaction. What is redox reaction? In which the oxidation and reduction occurs simultaneously. Okay, here we are seeing that this CO2, it has reduced to C6H12O6, isn't it? And it has been oxidized to O2. Okay, like that it reacts with fluorine also to form what? H plus ions plus fluorine ions plus oxygen is released out. Now coming to the hydrolysis reactions. Okay, in the hydrolysis reaction, actually what happens? The water breaks up and it reacts with what? The substance with which it is reacting. Like with P4O10, okay, what happens? This reacts with that to form H3PO4. What is happening over here actually? Here the hydrogen of water, the H plus ions of water is combining with this P4O10, isn't it? And naturally forming H3PO4. Okay. Likewise, it reacts with the N3 minus ions. Okay. This water first it breaks up into H plus and OH minus ions. Okay. This H combines with N to form NH3 and OH is left behind. So it goes on the hydrolysis reaction. Now next, this water, it forms hydrates, okay, with certain salts. Like you can see with nickel chloride, lithium chloride and copper sulfate, it forms hydrates. Okay, the corresponding hydrates in copper sulfate very easily have studied also. Yes, water of crystallization takes place to form CuSO4.5H2O. Okay, so this is all for today, beta. Hope you might have all understood it. Good day. Take care.